Little Pigs is a common bedtime story and fairy tale about three pigs who build three houses of three different materials. A big bad wolf blows down the first two pigs' houses made of straw and sticks respectively, but is unable to destroy the third pig's house made of bricks. This propelled us to ask the question, to what extent can the house of the three little pigs sustain wind in real life? Of which led us to formulate an investigation on the effect of wind speed on the durability of infrastructures. The control variable was using the same house for each trial, and having the same constant mass for each house, and was used in the same location, which was Miss Nicole's room. As you can see, the respective masses of each type of house for paper, wood, and plastic Lego.
The material of the hay house was replaced by yellow poster paper, of which it was cut up into strands of 2 cm by 12 cm and organized into 10 piles of 10 strips. The strips were then stapled together and stuck onto the center pole with the sticky tape and string, where the house was built in a radial shape. The material of the wooden house remained the same but was transformed into popsicle wooden sticks. The wooden sticks were organized in 12 by 10 and the roof was an open triangular roof. They were stuck together with sticky tape and masking tape on the top and bottom. The brick house was substituted with plastic Lego pieces, of which the pieces fell in love with each other, and the inside was filtered out.
The time came for the three little pigs to leave home and seek their fortunes. But one night, the big bad wolf came along and saw the first little pig in his house of straw. We substituted the wolf as a blow dryer.
Who's afraid of the big bad wolf? Open the door and let me in!
For our independent variable, we used varying wind speed from a blow dryer to substitute the wolf's blow at different distances from the house, at 50, 40, 30, 20, 10, and 0 centimeters using a meter stick to measure these distances. And we also used an anemometer to measure the wind speed at each of these distances at low and high power mode. Our dependent variable is measuring the distance in which each house fell, and the results showed that only the paper house fell at distance 10 centimeters using high power level.
Not for the hair on my chinny chin chin! I'll huff, and I'll puff, and I'll blow your house in! I'll huff, and I'll puff, and I'll blow your house in!
The same procedure was used for the wooden house and the plastic Lego house.
30 20
As you can see, due to the materials used to build the wooden house, including sticky tacks and masking tape, the house was very durable.
By the hair on your chinny chin chin, I'll huff and I'll puff and I'll blow your house in!
To see how much force was being exerted on the house, we used the equation F equals to 1/2 rho v square A, where rho is the density of the air in kilometer per meters cube, which is around 1.229 kilometer per cubic meter. V is the wind velocity and A is the surface area. For example, when the wind velocity is around 3.6 meter per second, the force that amount of wind gives is around 0.19 Newton. And so we apply the formula for all of the wind velocities, and these are the results that we got. As you can see, the amount of force needed for the straw house to accelerate is around 0.113 Newton.